Hey, welcome everyone. We're going to start with actual new theory of chapter 4, statistics and percentages. With that being said, the first theory is a bit, well, I wouldn't say not important, but it's very difficult for me to help you with this. Because we're going to start with theory A, where they say, well, you should be able to obtain information from a table, from an article, sorry. Because they say, well, articles exist, and in those there are a lot of numbers, and you should be able to then do exercises with an article with numbers in them. Yeah, and then the book gives you some tips, and that's also the only thing that I can do. So if you have an article or something that you have to do exercises from, which has a long story driven example attached to it, then try to explore the situation by carefully reading the article. Create a clear overview of the data, for example, in a table. What you also sometimes can do is mark stuff with a marker. Yeah, and the last tip really is not really even a tip that can help you when answering, but more at the end, be smart when rounding your answer. Um, yeah, so what they actually say is to do this part well, you have to read carefully. I wish you good luck with that. I can help you, however, with a practical example, but the example that I can give you then right now is theory B. So I'm immediately skipping over theory A and now go for theory B, and then let's take a look at something like this. And then theory B is very brief as well. Well, you can find stuff in tables, do stuff with it. Okay, let's take a look. The table below contains data on the number of kilometers cycled in the Netherlands, or to be precise, the total number of kilometers cycled by the entire Dutch population in a year. You can also find out how many trips were made by a bicycle per day. Okay. Take a good look at the labels of the columns. You have years, billions of kilometers cycled, number of cycling trips per person per day, and a population in millions. And we're talking about the Netherlands, so it's the population of the Netherlands. With one piece of information missing, I guess we have to figure that out ourselves later. At A, how many kilometers did a Dutch person cycle on average in 2015? Round to the nearest integer. Be sure that you know which columns you need. You don't need all the columns and all the rows here. If they're talking only about 2015, yeah, don't take a look at stuff that is in 2010 and in 2005. If we're talking about how many kilometers, I don't think I really need the number of cycling trips here per day per person. So what I'm focusing on here right now, and maybe I can mark it using this marker here. I'm mostly interested in this number, I think, and in this number. How can we use those numbers? Well, this is the population in millions. This is the billions of kilometers cycled. If I'm going to divide the total amount of kilometers cycled by the total population, then I know how much one person on average cycles. But be careful, because this is in millions and this is in billions. So what you would get is 15 billion kilometers divided by 16.9 million. And that's why it's important to know how to work with big numbers, which you were practicing in the prior knowledge. I would make billions millions, so 15 billion is the same as 15,000 million divided by 16.9 million. And on your calculator, you just punch in 15,000 divided by 16.9, and you find approximately 888 kilometers. They say here do not round at your intermediate step. Luckily, I don't have an intermediate step here that I can really round to, so here it's okay to round. Yeah? And a round to the nearest integer. Okay, integer, hele getallen. That's what I did here. What was the total number of cycling trips made by the Dutch population in 2005? Again, I think I'm mainly interested in this part here, right? And then maybe not even at every column, but not at least in 2010 and 2015. The total number of cycling trips made. Well, I do know that I make 0.82 trips per person per day. And I know there are 16.3 million people. However, this is per day, and here they want in the whole year. So what I can do first is take this number and multiply by 365. Then I have 299.3 trips per year. How many people are there? 16.3 million. So then multiply 299.3 with 16.3, and that gives me approximately 4,879 million. They round to the nearest million. Okay. So you see now why I give this an example, because theory A said it's important to know where to obtain information in a table. That's just as important. So know what you should use and what you shouldn't use. In 2010, so we're taking a look at this year now. The total number of cycling trips made by the Dutch population was 5.33 billion. So they give us a piece of information that's not in the table. That's important, I think. Calculate the population of the Netherlands in 2010. So we want to know what's right here. Round to the nearest 100,000. Okay. The total number of cycling trips by the Dutch is 5.33 billion. I know that if I'm going to convert that to days, I'm first going to divide it by 365. Here, I can do it like this so that I get an answer in millions. I can also do that later and then go to millions. Here to immediately do that, because otherwise, if I keep this in billions, then this is going to be a very small number, and then in billions. That's, I think, more difficult to work with. Why do we go per day? Yeah, because this information that I know here is also per day. So now I can do something with that 0.88 as well. I can now say, well, each Dutch person has made 0.88 cycling trips on average per day. So what you should get is 0.88, this number, times the population, which I don't know, is 14.60 million. And now it looks a bit like the exercise we did at B, but now in the reverse order. And this looks a lot like an equation, right? Some people now get sort of confused on what to do. But if I would ask you, oh, sorry, not the marker. Let's go to, then. If I would give you instead this, 0.88x is 14.60, then we now know how can I get the population, in this case x. Yeah, x is 14.60 divided by what's in front of x, so divide by 0.88, and then you can round that. Yeah, now we don't have x, we don't have a variable, we have population, but that's also a variable. And we don't have 14.60, but 40.60 million. But the same rules apply. I divide left and right by the number that's in front of my variable, which in this case is population. So I divide 14.60 million by 0.88. And it gives me approximately 16.6 million. We round to 100,000. If I would fill it in right here, you see you get an answer that's not too weird. It's actually exactly smack down the middle. If you would find, for example, 10 million here, that would be very weird. That we have a dip in population. Or if you find, for example, 500 million, yeah, that's also not feasible. That's the advantage of this chapter. You can very easily see if your answer is at least something that could be doable or not. And if it's not, then you know you made a mistake somewhere. And that's an example of theory B and also sort of theory A. I will also record, I think, 1 or 2 other examples of how to do this with tables and articles. If you find it difficult, watch that video as well. Good luck!